Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to find the end behavior of polynomials. So for instance, if I were to give you a graph, and let's say the graph looks something like this, or it's some kind of shape like this, I would say that as x approaches negative infinity, in other words the left, then f of x, in other words the y value, approaches negative infinity as well, because as we go left we approach negative infinity, and then on the opposite side I would say as x approaches positive infinity, f of x approaches again positive infinity here, because as we go right we're approaching positive infinity. Now this is very easy if I have the graph in front of me, but what if I only gave you a function like f of x equals x cubed minus 2x squared plus 10. And I asked you the same question, tell me the end behavior. Well, as it turns out, it's very easy to determine end behavior simply based on the leading term, which in this case is positive x cubed. So specifically, I'm looking at the degree here, and I'm also looking at the coefficient. Now, in this case, there's an invisible 1 in front of the x, but what's most important, I care if it's positive or negative, and in this case it's positive. And for the degree, I don't care about the number, I just care if it's even or odd. And so because of this, I can have 4 possibilities between the degree and the coefficient. So first let's talk about odd degree and positive coefficient. The graph would look something like this. Doesn't have to look exactly like this, but you can tell this was the first case we just did. And the result will always be as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x will also approach positive infinity. So that's the first case. Now let's do odd degree and negative coefficient. So in other words, this could be something as simple as f of x equals negative x cubed. So the graph is going to look something like this. And the one thing that's always going to be true is that as x approaches negative infinity, the left, f of x, the y value, approaches positive infinity. And then as x approaches positive infinity, f of x approaches negative infinity. So in other words, it's just the flip-flop of the last case. Now let's do the even degrees. So first we'll do even degree positive coefficient. This could be something like f of x equals x squared plus 2x plus 1, because all I care about is the x squared, and it's squared, which is even and positive. So then the graph will look something like this. But most importantly, as x approaches negative infinity, the left, f of x is going to approach positive infinity, and it's going to be the same for as x approaches positive infinity, f of x approaches positive infinity. So positive infinity for both, because from the left and the right it's going up. And then finally, the last case, which you should probably be able to guess what this is going to be for the end behavior, because it's the only thing we have left. Even degree, negative coefficient. Maybe it's something like f of x equals negative 9x squared. This is negative and even degree. And so the graph of this is going to look something like this. And as you can see, we're approaching negative infinity from both sides. So I'll write as x approaches negative infinity, f of x approaches negative infinity. And then as x goes to positive infinity, f of x still goes to negative infinity. And so these are the 4 cases we have for the end behavior. And now we're just going to look at some example problems where you're going to be telling me the end behavior just based on the function, no graph necessary. So here's the first one. We have y equals negative 3x squared plus 9x minus 4. Go ahead, give this a try on your own, and when you're ready to see the answer, unpause the video. Okay. So immediately I recognize that this is the even degree, because 2 is even, and negative coefficient, because it's negative 3. And so that's literally all the work I need. Now going into my answer, I just write as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches negative infinity again. So in other words, you just have to memorize that chart, those 4 options we have, just memorize it, and then there's no real thinking involved here besides just saying it's even degree negative coefficient. By the way, there are multiple ways to represent this answer. The way I have it, where I circled, that's one way. Another way people commonly write it, they'll write down, down, because down from the left, down from the right. In other words, negative infinity from both sides. So it really depends on what your teacher's looking for, but I'm going to write it in this format, which is the most traditional way of writing it. Number 2, we have y equals x to the 4th plus x squared minus x to the 7th. So go ahead, give this one a try. And here's the solution. So one thing you may have noticed, yes, I am trying to trick you. The leading term is not the one who's in front. It's whoever's degree is highest, which is the point of this question. Which means x to the 4th is not the leading degree. It's negative x to the 7th. And so that means we have the negative and odd case. And so immediately, I know the answer is going to be, as x approaches negative infinity, f of x approaches positive infinity. And then as x approaches positive infinity, f of x approaches negative infinity. And there we go. We're done. And what that looks like with the arrow representation is an arrow going up and then an arrow going down. Going up on the left side, going down on the right side. And that's it for that one. 2 more to go. These last 2 will be tricky. I have y equals 2x times the quantity x squared minus 4. A hint for you for this one, the first thing you should do is distribute the 2x. So with that being said, go ahead, try this on your own, and when you're ready to see the solution, unpause. Okay, so first thing I'm going to do, like I suggested, I will distribute the 2x to both terms, giving me 2x cubed minus 8x, but all I care about is the 2x cubed, which is the odd and positive case, which means I instantly go to my final answer. As x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. And there we go. That's it. Again, with the arrows, this is going to be down, then up. And then here's the last one I have for us today, number 4. Y equals parenthesis 2x squared plus 1 times quantity negative x plus 6. So go ahead, give this one a try, and when you're ready to see the answer, unpause. Okay, so I'm going to do a little trick for this one. If you distributed and FOILed all 4 terms, then that's fine, you didn't do anything wrong, but let me show you a trick. Since I only care about the leading degree, I only have to FOIL the very first one, 2x squared times negative x, which gives me negative 2x cubed, and the rest don't matter because I only care about the leading term anyway. This is the negative and odd degree case, and so therefore the answer is as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches negative infinity. And there's the answer, and with the arrows, it's going to be up and then down. And that's all the questions I have for you today. Hopefully that makes sense. If you still have any questions, please post them in the comments. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.